Not gonna lie, this is actually like my favorite subject in the course. This is my favorite topic. So I hope if I'm going a little like too fast or in depth or anything, just kind of sir, tap the brakes. That's fine. I get excited about arrays. So, but seeing as we have a test tomorrow, are there any questions about the test before we get started? Yeah.
One thing that I saw, you posted a sample of a test that was from 2018.
Yeah.
I was just wondering, that test has about 12 pages. Is that test going to be that long?
I don't know what the page count is, but it's, in terms of length, that is roughly representative, yes. Yeah. That's kind of the intention of that one, is like, the test you're about to write is reasonably well represented by it. It certainly, like, the questions will be different, obviously. But, in terms of like, what can you expect in A section, what can you expect in B section and C section, that's kind of, that's where it is. So, is someone trying to get in? There you go. You're welcome. So arrays then. Unless there are any more questions about the test. All right, so arrays. I always like to start off with some basic definitions when I discuss this topic. So within your intro programming course, you probably did lists. Am I right? Did you do tuples? No? Python actually has 5 elementary data structures. Lists that you study, strings count, right? Tuples, sets, and dictionaries. All of these except sets are useful. I suppose sets could be useful under certain circumstances. So here's the one thing that Python doesn't have: arrays. An array is not an elementary data structure in Python. Everything is hid behind all these dynamic data structures. If you took the mutability of a Python list and you combined it with some of the static properties of a Python tuple, you get something approximating an array. So arrays are essentially the most basic data structure that exists. Arrays exist in C. That's where everything comes from. Much of the time, arrays are kind of the thing underlying the thing you think you're working with. More so in our sort of static compiled languages than in our, loosey-goosey dynamic languages. So let's proceed to the definition of both an array and a list. Because I will warrant, I'll put money on it, I didn't actually explain to you what a linked list is. You probably don't even know that lists are linked lists, right? So, all right. The problem that we are trying to solve. When you are using data inside of a computer, you're declaring variables. You will occasionally find yourself in a situation where the temptation is to do something like this. Int x1, x2, x3, x4. You kind of just need a group of variables, right? Often you'll end up numbering them numerically like that, right? Well, this is quite a common thing. we have structures in place to help you deal with this sort of complexity. This should be an array of 4 variables, right? Integer array x. We'll worry about how to declare it as having 4 spots in it later, right? So we should think about the memory model, right? So the simplest way to represent all of these variables in memory is to just put them side by side, right? If we declare our variables in this way, if this is a if this is a map of our memory, we end up with a value over here, x1, a value over here, x2, x3 over here, and maybe, x4 over there. Because of the way that memory is assigned, it essentially ends up in a random position within your field of memory that your program is allowed, right? Sure, all right. We know how to get to each of these individual pieces of data. It's not a big deal that they're scattered all over memory. However, you do get certain advantages by clumping it all together. Declaring, in fact, let's call it something else. Let's call it ARR. Declaring 4 adjacent cells in memory and giving it a name, right? We declare an array. That's what an array is in memory. Am I making sense so far? So, you can see that this is a very basic, this is a very elementary sort of way of thinking about data, right? If we have, 5, 10, 15, 20, here we would have 5, 10, 15. So, one of the advantages of an array, if we know the starting point in memory of this group of adjacent cells, and we know how large a single one of them is, right? This is the bit width of the data type, right? How big are integers? 32 bits. How big are our shorts? 16. How big are longs? 64. So you can see how this width here in memory would be 32 for a regular integer. It would be longer for a long one, shorter for a short one. Long and short, they actually do physically use up more and less memory, right? Generally speaking, your memory will be addressed at the level of the individual byte, right? So for 32 bits, if this is memory address 800, then, and it's 8 bits, if it's addressed on 8 bits, and this is 32 bits this way, what's this memory address? What's
840, some 8 bits in there.
What's 32 divided by 8?
Divided by.
Yeah.
Be 804.
It'd be 804, that's right. So you can see the memory address at which these things are stored can be easily calculated from 2 pieces of information. How far over we are, and what the bit width is of the thing that we're counting. Yes?
But why you divide by 8?
So let's examine this memory cell a little closer, right? So let's say we have, let's say this tract is a region of our memory. Let's say that this is address 800, right? 801, 802, 803, 804, 805, ... right? Or let me put in one more. 806, right? ... n. So the distance between 800 and 801 is 8 bits, right? 1 byte. An integer is 32 bytes. So 8 bits plus 8 plus 8 plus 8 is 32. So the space occupied by an integer, one more, is that much, right? So that's why the next number in the array will be addressed on that one if we're dealing with integers. If they're shorts, right, it'll be half that size. And if it's longs, it'll be double that size, right? So you can fit 2 shorts in the space of 1 int, 2 ints in the space of 1 long, etc. Right? So, does that make sense? Does that answer your question? Awesome. So, the point here, right, is that to access any particular element of the array, we can do that very quickly. We must perform a very simple equation to get there. It's your starting address plus the width times the offset. Right? So, with arrays, this, like the actual value of this guy, is the address in memory where the first item resides, right? So that's your starting value. This, in memory, is your starting value in memory, right? So array in this case would be actually equal to 800, right? So because this element in memory is located at that address, the first element of the array has an offset of 0. Now, how do we access stuff out of data structures again? What's the first element? If I ask for array at 1, does that give me the first element? That gives you the second element. Array at 0 is the first element. So this is why. This is why 0 indexing happens. It's because array access with offset 0. So that's what this number means. This is the offset value. Does that make sense? Good! So, that's how arrays work in memory. Question?
What's the difference between this and a Python list then?
I was just about to get there, actually. Yeah, so, and it's not just Python lists, it's lists in general. So, the big difference between an array, this is an array, and a list is this. A list is not an adjacent series of values, a series of slots in memory. A good way to think about memory, a good mental model for it, is as a series of cardboard boxes, right? And anytime you put something into the cardboard box, whatever was in there falls out the bottom and then closes again. That's a good kind of mental model to think about memory, right? So we've got an adjacent sequence of boxes, right? What a linked list is, it's a series of boxes. Each number in a list is actually 2 boxes. The first box is the number you're holding. The second tells you where to find the next box. I'll show you. I know, it's a little strange, right? But it's pretty good for certain circumstances, right? So we're back to this kind of a thing where we are scattering things randomly through memory. Right? So let's say this was item 0, 1, 2, 3, and 4, right? Item 0 points to item 1. Item 1 points to item 2. Item 2 points to item 3. Item 3 points to item 4. Item 4, because it's the last item, points to nothing. Right? And our list, like the artifact that you work with, the thing you think the list is a pointer, once again, to the first element. Right? So that's what a list looks like. It's a little scattered, right? There are advantages to doing this, right? But, yes, sir?
So arrays will be typically faster than lists in a way?
For certain operations, if you're looking up an item, because you can get to that memory address with a simple calculation, you can do that very quickly. In a list, the actual memory location of each node is random, so you cannot access the middle of a linked list quickly. What you have to do in order to find any element in the list is you actually have to walk the data structure. You have to travel through each node to get to the one you want. This takes time proportional to the size of the data structure. Right? Yes?
This question, so if I want to access like the 30th item on the list, I actually have to go from 0 all the way to... Okay.
Yes.
Yeah.
And if you want to access the 30,000th
Yeah.
item in the list,
Yeah, you have to go through every single one of them.
right, so you begin to see
Yeah.
there are disadvantages to doing it this way, right? Whereas with this guy, you declare like a million elements, you always know where the 30,000th item in that array
So what's
is.
the formula for this one for the array? Is that just like an arithmetic sequence?
Yeah, it's very simple, right?
They look very similar.
Yeah.
Yeah.
So why would anybody use this? Well, you can modify this much more quickly. Let's say that you wanted to add even a single new item to the data structure, right? Let's say we have a new thing over here. The fastest thing to add it to is the front, right? Let's say this is like -1, right? It's very simple. You just remap this pointer to point up here. You initialize it so it points there, and boom, you have a new item in the array, or you have a new item in the list. Very quick, right? Here's the thing about this guy, right? If the memory here is used, and the memory here is used, you have to move it in order to make it larger, right? So you have to copy the whole darned thing to another region of memory in order to be able to expand it by even one slot, right? Which is going to take an amount of time, once again, proportional to the number of items, right? So, lists are preferred for dynamic memory operations, right? Arrays are preferred when the number of items can be strongly decided, right? If you know going into it how big this thing needs to be, you can simply declare it, work with it, and it's fast. If you don't know how big the thing is going to be, the list ends up being more useful in the end. Generally, lists are favored by dynamic languages. You know, like all of your interpreted languages generally favor them. You know, Python, JavaScript, PHP, etc. Your static pre-compiled languages generally favor arrays. We're talking C, C++, Java, C#, Rust, right? Interesting note about these two actually. Due to advances in processor technology, lists are actually kind of over time going the way of the dodo. for a very interesting reason. Despite the time savings that you get by being able to add and remove nodes from this very quickly, arrays are Arrays are still like pulling ahead of lists in applications that lists would typically dominate. Why? A little thing called CPU branch prediction. So this is a thing that that modern CPUs will do. They'll look at a program and they'll say, I've got an if statement coming up. I'm going to use my multiple cores to pre-compute the results of both of those if branches, and I'm going to use whichever one turns out to be correct at the time. CPU branch prediction. It's pretty cool, right? You can't really do it with these because the actual location in memory of the thing you're looking for is random, right? So you can't really do prediction on these guys, but these you absolutely can because everything's always in a fixed location in memory. Yes?
So is there a reason why arrays, you have to specify which data type goes into an array, or is it just because Java hates you?
No, it's because it's because of this constraint, right? Like, you can't, because in one of the known properties of lists in all of the dynamic languages is that you can have them as heterogeneous, right? They're not monotyped, right? You can put strings in them, you can put booleans in them, you can put integers in them, doesn't matter, right? With this guy, the memory offset calculation is dependent on each cell being the same size. So that's why in Java it must always be monotyped, right? And we know that because I explained the memory model to you, right? You really should know something about the memory model if you're going to be a programmer. So, any questions about that? Yeah? Yeah, that surprised me when I heard it, that lists are falling out of favor. That was interesting to me. Anyway, so shall we talk about Java then? JavaScript. If everybody could open up IntelliJ, that would be fan-flipping-tastic. Just open up a new project, doesn't matter what you call it. So just make a new, a main class for now. Yeah, this is kind of this week we're kind of lighter on the, declaring methods and making new classes kind of stuff. So, behold, the syntax for creating an array of integers. Integer array, x is equal to new integer array of size 10. Sorry? Square brackets means array, yes. So, and you should think of this as type information, right? Now, this is similar to, but not quite the same, as our syntax for declaring an object. We are certainly using the new keyword, but can anybody spot the difference?
We're not using curly brackets. Or not curly, just regular brackets.
Yep, which kind of brackets are we using?
Square brackets.
We are using square brackets, yes. So, similarly to variables and object types of other sorts, it is certainly possible to initialize or to declare an array without initializing its size. This is syntactically valid. We can say this is going to be an array and decide what its size is going to be later. This is particularly useful because you can make that a instance variable or static variable of the class and initialize the size inside of a constructor or something like that. Right? So, from here, there is another way of doing this, actually. There we go. Z. A third way of declaring an array is as such. This is probably something you've seen something similar to this before, right? So, this you could call an array literal in the same way that, string groups of characters in double quotes are string literals. We don't have to use the new keyword. We don't have to declare the size. Why don't we need to declare the size?
Because we already have the amount of stuff we want to put in it.
Precisely. The size can be inferred from the size of the literal. Very good. Any questions so far? All right. So, as we can see, array access in Java is pretty much what you expect, right? Hopefully this isn't a surprise to anyone. Similarly, we can assign two elements of arrays in a very similar way to how it's done in Python. As such. So far, so good? Good. So, upon initial creation, an array of anything in Java will have the default initial value for the carrier data type, right? So, in this case it's integer. What's the default value of integer? 0. What's the default value of float? Someone else? Float or double, what's the default value? 0, sure, 0.0. What about booleans? False. What about strings? Null is correct. Empty string is not correct. Strings, remember in Java, are objects. All object types have null as their initial value. Right? So, good.
Oh, I have a question, sorry.
Yeah, absolutely.
Why do we add like an array on the public static void on the string?
Ah, here?
Yeah.
Very interesting question. So, it's a bit of a digression, but since we're here, so, you know this interaction down here? You know how we call the stuff we output standard output, and the stuff we input standard input, right? When you call one of these, like when you execute one of these programs, right? This is what this looks like in the command line. Yeah, I'll put it right here. So, to compile this in a command line, at least in Bash, you would call javac, right? You would then specify the file, main.java. This would compile the program. Any compilation errors you had, that's where you would get them. Then, to execute, because this is Java and things run inside of the Java virtual machine rather than natively in the operating system, you have to invoke Java and then I believe main.class, which is the file, or just main, I think just main is fine, which is the file that is produced when you compile it. But here's the thing, you can provide command line arguments. So you could say, here, 5 false temporary folder, something like that, right? You can pass additional arguments when you run the program. This is something that's hidden from you in IntelliJ. Like there's certainly like a way of doing it. I'm actually not quite sure what the way of doing it is. But this is kind of something that IntelliJ kind of obscures from you because like the fact that 2 invocations are required here, but it's got 1 play button kind of also obscures that from you, right? In the old days, you used to have separate compile and run buttons. I don't know what kids these days and their fancy schmancy editors, I don't know what to say. But anyway, in this particular instance, right, the string array args would have the value, and you can just use it in the main, right? It would have the value of 5, comma, false, comma, temp. And you could just use it in your program,
Right.
right? So that's what it's for.
And that's like an array.
Yes,
Yeah. Okay.
it's an array of strings.
Okay.
Yeah.
That makes sense.
Now, I might be telling lies. I think technically speaking, like the Java invocation itself and main, like all of the arguments here, not just the ones past this point, are included here, if I recall now. But it's kind of like that. That's what it does,
Okay.
right? So yeah, that's what string array args means. And as a matter of fact, your main method doesn't have to be void. Your main method can return an integer, right? Now you may be saying to yourself, but like, what's it returning an integer to, right? And the answer is that command line interaction. So basically, the convention in command line interfaces, particularly Bash, when a program returns 0, this is called the exit status. When the program returns an exit status of 0, that means everything is fine, I terminated normally. When it's a non-zero exit status, this means there was a problem which occurred, right? And the actual value of that exit status is an error code, right? Now, way, way back in the days before the internet, and perhaps even in the days before exception handling, the return code, the error code of a program was something that you would be using a program, it would give you an error code. You would then like say, ugh. You'd walk to a room in your office, you'd grab a binder that was this thick, you would lay it down on your desk, and you would start thumbing through the appendix of what the error codes were to see what, some poor developer at some point wrote about what this error code means. That's like, these days programs tend to try to explain their own error codes a bit more than that, but this is back in the old days, right? Yes.
So would it show an error if you change that 0 to something else, or?
Good question. A typical one is -1. I'm interested to see what IntelliJ does with this. Yeah. All right, so they, all right.
Sir, for some reason I'm getting an error or return.
Yeah. That's interesting though. There must be some kind of thing you can enable to allow non-void main.
Wait.
This would be so much easier in C.
See that? There we go. Okay, no. Oh, there we go. It is working.
They've encapsulated it. All right. All right, fine. They have methods they want you to call. Typical Java. All right.
IntelliJ for me just doesn't let me run the program if I change void to int.
Yeah. Well, see, it'll compile, but it won't it's not. The compiler is fine with it. It's the runtime engine that doesn't like that. That works in every other language. I'm just saying. All right. So anyway. All right. Anyway, back to arrays. So let's say we have an array called X, and we want some values in it, right? Let's say, though, the array is too large to really be workable using this method, right? Oh, by the way, you guys want a handy tip? This is cool. Watch this. Best random number generator. I think this is the one. Let's see, is it? Yeah, this is the one. This is the best random number generator, all right? Because you can do stuff like this. Give me 100 random numbers between 1 and 1,000. Duplicates allowed. There you go. Roll. There you go. Ta-da! But even more interestingly,
Mind if I use the washroom, sir?
yes.
Thank you.
Yeah, you don't have to ask my permission.
Force habit.
Yeah. You can change it so that you can like format it as CSV, which is like comma separated, which means you can just copy this straight into your programming code. And boop. Oh, come on. Copy. Copied. Paste. There you go. Pretty cool, right? That's how I when I'm like doing, assignments and stuff, that's how I generate my random arrays. If you're sitting there picking 100 random numbers yourself, you are working in a deeply suboptimal manner. So, human beings are not good random number generators, but neither are computers, so. All right, so anyway, let's say we wanted to apply some kind of mathematical formula in order to generate the numbers in that array. Well, can anybody guess what we're going to stick that thing in?
The function.
Not a function. One of our elementary control flow structures.
For loop?
Yes. For int I is equal to 0, I is less than x dot length, I plus plus. There we go. Let's say x is equal to, or x at I is equal to I times I. And there you have a list of all of the squares from 0 to 1,000. Pretty cool, right? The for loop, the humble for loop, really starts coming into its own now that we have arrays, right? The index variable here, that's like, you know all of these like simple kind of toy examples that we do of loops of like, get a number to count down from 10 to 1, then say blast off, that kind of stuff, right? The reason that we drill you on generating sequences of numbers is because, like, it's not for the sake of the sequence of numbers itself, it's because those are array indexes eventually. Well, now they are array indexes, right? So, if you go by 2s, you get every other element of an array, for example. So, all right, let's see it. S out x. S out. There we go. Boop. Ooh. Is Java being Java again? Well, let's see here. Let's see what it has for a toString method. And it's the same. Because the toString method is automatically called when we pass something to print line. So, or when we concatenate it into a string. So I think we should probably do something about that, right? So, everybody in the class, I would like you, as an exercise, write me a method inside of this class which prints the string, or prints the array. I would like you to print the contents of the array all on one line, comma separated, ideally with nice braces on either side. For arrays, the brace is curly braces. Okie dokie, we'll take 5-10 minutes to do that. Chop chop.
Question? Sorry.
Yes.
You want them to be printed like as a one, right?
On one line, yeah.
Yeah, so, okay.
Use print instead of print line.
Oh. Wait, actually,
Very good. Encapsulate that in a function, and I'll be happy, happy, happy. Sorry, method. Java. So this is across the site. Request failure means that you're requesting data from a, there's an option you can set for this. If I here. Oh, wait a moment. This is a local file.
Yes.
So where is this file state.json?
So it's kept on here in AD. Yeah, so here's the JavaScript file. It's in AD. There it is.
If you put this on CSV,
Okay.
the problem that you have right now is you can't make fetch requests to a local drive, right? Not without XAMPP anyway.
Okay. Is there any way to read a local JSON file in JavaScript?
Probably, you should look it up.
Okay.
But let me show you. That's how we generally an older program. So it works. Basically emulates a server.
Yeah, I just want to do this just for fun and apply my knowledge. Yeah.
You're running ahead of the course.
Yeah.
It's an excellent.
Yeah, this is my first time taking this course.
Yeah, right now you're at like end of March, April territory, of course. That's fine. I'm totally okay with that.
Yeah, I just want to get the hard stuff for this overall project out of the way.
Yeah. So if you take a look, local host. No. Host. Yes, I know it's not secure. What's my port number? Yeah, there you go. So this is the running XAMPP folder. So if you go to third point, stuff, XAMPP, page docs, you make a new but that's, you'll notice that it's not complaining about the
Yes.
cross-site thing.
Okay, okay, so is there a way to make a JSON file, a local JSON file?
Look it up.
Okay.
Get a textbook.
Okay.
Most likely, yes.
Okay.
So how do we do with that? We get it printing? Hey, who's still working on it?
And I forget how to call the methods here. Or is they same class?
You gotta declare it static. Right? Because you can't call instance methods from a non-static, or from a static context, so the method itself also has to be static.
But you wanted a
Encapsulated in a method, yeah. And also printed on one line.
one line, yeah.
Yeah. Just exchange print ln for print, and that's all.
Did some correctly.
Yeah. You were supposed to do it yourself. Arrays not too straight.
So this is that would be good.
Well, I mean, look at it, it works. That's not the point though, you didn't do the exercise.
I've gotten fed up with Windows installed with this adventure. Oh, it's switching back to Linux. I have Linux on my home computer. I just came with Windows and I never bothered to.
When I get a new computer,
I was too lazy. I was going to a party that night when this thing arrived.
yeah, fair enough. It's like, basically I was kind of like done with letting Windows set itself up when it started asking me whether it's allowed to know where I live, All right.
I just can't get over the lack of consent for updates.
Oh yeah, no, it's,
Would you like to install this update now or in 3 days?
yeah,
Sir,
yes.
I can't run.
Well,
Wait, do I have to give it a return?
I'm gonna do like,
Actually return today.
this one wouldn't have one, so let's do a public static print array int x, there we go. Public static void print array, there we go. We can even copy paste that. Thank you for that, by the way. There we go. Instead of assigning a value, we can print the value. Just like that. Print the opening brace. Print the closing brace. And we can print array x. There we go. Let's run this, see what it does. Oh, interesting. Oh yeah, you gotta index that thing. Boom. There we go. That shouldn't be line, that shouldn't be line. There we go. Now, this is almost perfect, but you'll notice the last item has a comma, So, one way we can fix that, also put this in there. One way we can fix that we can loop to one fewer item. We can then print essentially the closing brace plus that last item, which will be x at x dot length minus 1. There we go. Running that again. You can see, whoop, we no longer have that embarrassing brace at the end. Very good. So, any questions? Okay. So, now we run to an interesting new construct. So, many languages have a special style of for loop, the purpose of which is to loop over data structures, right? These are generally called for each loops, right? In some languages, it's explicitly for each. In other languages, you have some variant on for syntax, which accomplishes that same thing. The problem, of course, is that every language likes to call them something slightly different, right? So, in Java, the unfortunate term that they have for the for each loop is the enhanced for loop, which is like, I hate that term. It's the worst. I hate it. Why do you call yourself? Like, it's such a mouthful, too. Enhanced for loop. It's like, it's a for each loop. Everybody calls those for each loops. Come on, Java, get with the program. But, you know, I suppose it's in keeping with Java being the most verbose language that exists. So, by the way, you remember for loops in Python? Those are for each loops, right? You may have noticed that our default for loop in Java looks a little and behaves a little differently. This is because it's a C-style for loop. In Python, they've kind of moved away from this ethic to some degree, but one of the original design ethics in Python was that there should only be one way to do things. Strange, right? But so the for loop was mapped to a for each loop because if you want a regular loop, just use while. We have while loops, just use it, right? You have a question, sir.
Yeah. For some reason my thing's recording, because it says expected curly brace at the end, even though there's literally one at the end.
Let me take a quick look for a hot second here.
Oh.
There we go. All right. So, for each loop. We call them enhanced for loops. So, this is the syntax. For int x, or let's call it something else, element in, let's make it z this time, which isn't declared yet. Let's put it where it is. There we go. Int sum is equal to 0. Sum plus equals z, or sorry, element. go. S out. Sum. There we go. And there you have it. So this is Java syntax for the for each loop. The equivalent Python would be for element in Z. I seem to recall.
Or just regular for loop in Python,
Yeah.
or I in range.
Yeah. Oh, they did it that way. Did they for you? They didn't do over data structures. They only used range.
All I can remember is for I in range from the Python class. They might have, but I do not remember in the teacher covering that.
I'm just going to be sulky in the corner for a moment.
Yeah.
All right. Well, I have to do this now. You forced my hand. Bloody online Python interpreter.
I think they did it with a list. Vaguely remember, like for I and like a list. I think, at least in the final exam. I'm not sure.
List is equal to 1, 2, 3, 4, 5, 6, 4 element in list print element. Oh, no, don't share. Stop it. No. Who wants to share that? There you go. So yeah, funnily enough, this works for like all data structures in Python. Basically the way that in Python they're defined, there's an iterable, like in the object there's an iterable method, I believe, or an iterable property that it tells you how to get the next element out of these things. So yeah, you can do this with lists or tuples or dictionaries or sets. Or even, I think you can pull characters out of strings this way. Let's try that out. Boop. Yeah, works that way too. So, yeah. So, like, you know what range is even doing?
It's doing a range from a start to an end integer.
Yeah, but like, what's it actually outputting?
A
Stupid thing. Cast as list. That's a good Python trick. There you go. So it's actually range on the fly is generating a data structure. That is what the for loop is iterating over. So that's how it actually works. I taught Python many years ago. Can you tell? Before I was famous for hating JavaScript, I was famous for hating Python. Then I started teaching JavaScript, and I'm like, maybe Python's not so bad. So yeah, so that is the enhanced for loop. Let's take, 404, time not found. Now it's 405. What's 405? 403 is forbidden.
Moved? Is it like moved or redirected?
Redirected? Maybe. Yeah, I think it's redirected.
method not allowed.
Method not allowed? Well, I'm going to defy the time then. Because I want you to write a method. Nah! So, you should be able to take this example that I did on the board and real quick make a method that produces the product of all of the items in an array. Which is to say, multiply them together. Alright? But encapsulate that as a method, please. This you should be able to do very quickly.
multiply them together, you need 1.4 times 9 times onwards.
Yeah. Yeah. There's actual mathematical notation for what we're doing. The sum is this. Right? And what we're doing now is this one. So you may have seen big sigma for a sum, but there's also big pi for product. Math. Mathematics. Everything is math. Math is life.
Something happened fine.
Something happened?
Just kept between brackets.
Oh, interesting. Well, yeah, that's because you're printing brackets in your loop.
Oh, okay. So do I just get rid of it then?
Move it move it that line until after the loop, and then put in the loop something that prints an element of the loop.
What, public static void right?
No, just outside the loop, not method.
Here?
Not that one. The one that's in. Just move that. So.
Here.
Yep, and inside the loop, you'll need to print elements of the array.
So, what, like just elements of the array, just call that, or?
Well, use access, use array access, square braces. Similar to up here. Question?
I think I did something wrong with this because at some parts the things make the name like that.
That's not a problem. Try changing the
Oh,
data
no,
type to
errors.
long.
No, just give me some errors.
Wow.
What is wrong, please?
So in first, that wasn't the problem. Okay. So just Control Z. Again. Again. There you go. Inside the for loop. That's where you need to put it.
Oh, this.
So, how many people got that working? No?
I'm just gonna have logic for that. Phil.
Do it again.
Might be +1. And the last one will be weird.
In the first place, system.out.print.
Oh, okay.
It did it again, sir.
Yes. Because you moved this line inside of the loop.
Can you tell me what it
No, I told you to write something that accesses the element of the array inside the loop. Prints it.
So,
Like you're printing a variable.
so confusing.
You meant change sum to long, right?
Yeah.
Long here as well. Try doing that as the expected.
Yeah, yeah.
So that means I have to change x up here to a long.
Yeah, unless it casts. And then long. might automatically pass as yours.
This one here, still saying fire space.
Oh! Oh, one moment. Here. So you're not indexing the array. That is the element of the array. Right?
Now it's all zero.
Hmm.
Mario all zero.
So, the reason that it was flipping from positive to negative is because of overflow. So, anybody who's interested, I'm going to explain integer overflow for the next few minutes. So, So let's add some numbers in binary. Yes.
Isn't integer overflow the glitch in the original civilization that caused Gandhi to start building nukes?
Oh yes. Oh man, it is. So in the original Civilization game, or I think it was either Civ 2, one of the Civilization games, like each of your different leaders had a aggressiveness score that was tracked in an integer. Now, you could modify another civilization's aggression towards you score by, doing nice things with them diplomatically, right? So you had India, the leader is Gandhi, and has the lowest aggression score of all of the civilizations, right? So, what happens when you lower it past 0?
Goes to negative.
It flips to negative. But not just flips to negative, or sorry, no, I've got it reversed, I'm sorry. It's like a passiveness score, right? So if you increase passiveness or friendliness by one more tick, it overflows and becomes the most maximally negative value, right? Which means that this doesn't usually happen until late game, and then just out of nowhere, Gandhi starts destroying everyone with nukes, and it's the nuclear Gandhi glitch. There are other there's this one. Okay, so there's this game called Star Control 2, and in this game, It's a little bit like Mass Effect. It's actually the game that inspired the Mass Effect series. And so you have this alien species that's at war with another alien species, and you ask these guys, why are those guys so evil? Because they're so evil. They're like big space spiders that just run up and they worship gods of death, and it's their duty given from their gods to bring as much death into the universe as possible, and that's their thing, right? And it's why are these guys so evil? And this other species is well, it's an interesting story, actually. At one point, they were the most noble, best, pure aliens in the whole galaxy, and then they got better by one more, and they became completely evil. So, anyway, so let's do some math. So let's imagine that we have some binary numbers. We'll pick a small one. Let's do a 3-digit number, right? 0. If you add 1 plus 1 you get what? 0, 0, 1. If we add another one,
0, 1, 0.
0, 1, 0, 0, 1, 1. Right? There we go. Now, what happens here is interesting, because this is a feature of 2's complement arithmetic, which is the way that negative numbers are represented in computers for various reasons. So, you guys want to know why we don't just like set one bit to positive or negative? Because that's what they do in floating point, right? Here, yes?
It's because they use one bit to assign negative or positive numbers.
Yeah, that's there's a reason we don't do that for integers. All right? Anybody care to guess why? If this bit is a positive negative value, what you end up with are positive and negative zeros. Right? You end up with 2 values for 0, a positive one and a negative one. Now, here's a problem with that, right? Because of the way that equality works inside of a CPU, these things would not compute as being equal, because they have different binary values, right? This one would be 0, 0, 0. This one would be 1, 0, 0, right? Those aren't the same bits, so it's not equal. But is 0 equal to 0? Generally, yes. So that's we can't just, for integers, assign one column to be the positive or negative sign, as convenient as that would be, right? So basically, how it works is that 1, 1, 1 is given a value of -1, and then 1, 1, 0 is -2, 1, 0, 1 is -1, and, or do I have this wrong? 3, and then 1, 0, 0 is -4, the most negative number. So let me ask you, yeah, yes?
I figured out why it was showing zeros.
Oh yeah?
The long max value. It
Oh,
overflowed with long.
oh, even better. So, if we are performing addition, if we have 0, 1, 1 and we add 1 to it, you know, 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. This becomes a 1, that's a 0, that's a 0. And, you know, we go from 3 to -4. So in the case of integers, 3-bit integers, 3 plus 1 is equal to -4, right? And this is unfortunately just the case. There's no good way around this. This is just something we have to deal with, because, you know, everything else is worse. But fortunately, it also means that if you have -1 and you add 1 to it, you know, add 0, 1, 0, 0, you get, you know, 1 plus 1 is 0, carry the 1, 1 plus 1 is 0, carry the 1, 1 plus 1 is 0, carry the 1, but of course the carry bit is lost, so you end up with 0, 0, 0, so -1 plus 1 is 0. That's good, right? So yeah, so that's integer overflow. That's a thing that you have to worry about sometimes. Most of the time, you don't have to worry about integer overflow. On 32 bits, I think this occurs around the 2 billion mark, somewhere in there. But yeah, that's how numbers work. Very good. Back to arrays. So, basically, arrays are very important. If you get the logic and you can like logic your way around arrays, you're a programmer. It's like facility with arrays is like if you get a one-dimensional array, you can fairly easily move to two-dimensional arrays. You know, you can work in n-dimensional arrays. By the way, you know Minecraft? You guys know Minecraft, right? Minecraft is a three-dimensional array. Boom. This is what you do. You take a three-dimensional array, you map numbers to like images, and you write a rendering engine, and you have Minecraft. Right? And maybe you like put a player in there. That's it. That's Minecraft. So let's write that product function. Public, static. In this case, I think I'm going to have it like actually return the product from the method rather than, rather than just print it directly. It's a little nicer, right? Int array x. So, I'm going to use an enhanced for loop for this. Integer product is equal to 1. Note the difference with sum here. Anything multiplied by 0 is?
0.
So 0 does not make a great initial value for multiplication. For integer e in x, the colon should be pronounced in. Product times equals element, return product. Note, you have a times equals operator. Yay! Make sense? Any questions? All right, very good. Okay. Now, we need some practice with lists. Or, blah. We need some practice with arrays. So, let's pull up the document full of practice problems. That is on, oh, I need to make this,
Well, you go back to
publish that, there you go.
Finish the code.
Yeah, let me just assign and then I'll put it back up. All right. So if you take a look at exercises for week 6, there we go. There are lots of them in here. Are these the ones I'm looking for though? Let's see here. Yeah, this is what I want. Okay. So, this is a good one. Above average. Return the number of elements in the array that have a value greater than the average of the array. There's actually an easy math formula for that, but let's actually calculate it. So, above average. And I'll put the code back up. There you go. Actually, no, I'm thinking, maybe I'm wrong about that. Yeah, I'm wrong. I don't think there is any easy formula for it, actually. average of all elements. Whoop. Mhm. What was the company? Oh, yeah.
Do you remember Sophie?
Yeah, yeah, yeah.
Interview today was about her job role, and it seems like the students are really engaged or getting more jobs. It's not this silly stupid clue that all the internet forums say it is.
I mean,
There's so much to be done.
Well, here's the thing though, it's gonna lag the actual, like, state of things, you know? Like, here's my theory, all right? So, a thing that happened during the pandemic, companies overhired.
It was crazy.
Right. But like, there was a natural correction to that just at the moment that AI came onto the scene. Yeah. Oops, sorry. Yeah.
Alright, so I think I got it.
Very good. Yeah, that looks correct. All right. So,
the first step to solve this problem, write a function, or write some code that calculates the
Do you want
average
us to
of all
make
those.
another class for this?
No, you can do it in the same one. Yeah, like,
I know because I remember it was crazy.
yeah, and like, I do believe that like, companies were kind of sold on the idea that they could replace developers with the chat algorithm for a while, you know? So I think they did let some people go, maybe for that reason.
Yeah.
But like, the problem is,
Oh, just COVID money was drying up. There's a lot of money around COVID time.
yeah,
Stimulus, money.
yeah, not to mention the economy's just kind of generally crap the last, like, since the pandemic in general.
Yeah.
So like, you know, that's gonna affect every industry, right?
That's-
So, yeah, but, you know,
Yeah.
the meme very quickly became, sure, we fired half the developers, but we had to double the size of the testing department.
Yeah, stuff like
Right.
that.
So I think that we're probably like entering the correction, which the correction will be away from nobody has any jobs ever for any reason, you know? Yeah, like I even had some, you know, ignoramus making a comment on the YouTube videos for this class saying programming jobs. It's like, yeah, well, you know, people do still get jobs though, you know? So there's hope.
Yeah, this was.
There's hope. Especially if you're good, there's hope. You know.
About the average thing.
Good, yeah. Now, you might want to make that double, right? Because when you're doing the division, you're throwing away the tail. But, you know.
Oh, this one is, I just made it percent alone, then just shrunk it down to 100 instead of 1,000 values.
Yeah. How are we doing with this one?
So I tried to make up class with that work.
Well, it's not going to share any of the data with any of the rest of this. You should
Practice class.
no, you should write a
method inside of your existing class. Yeah. You got it? To declare a method, you got it. You don't need a new class, but you do need to get it outside of this method. So if you again. Yeah, precisely.
Why is that? I'm just thinking, fourth class, the fourth better to be able to be.
Yeah.
I'm mind blown too.
I mean, I did do the review last week, but, I mean, well, I mean, if you wanna pass, you gotta come to class. You know?
Yeah, because, some of my new taught this semester was taking this class for the third time. I think he's the first year. And I was like surprised, like, oh, okay.
Yeah, I mean, you know, especially if you're repeating the course, like, clearly your knowledge the last time around wasn't sufficient to get you over the threshold, so you people generally are bad at acting with their own interests, actually.
Yeah, sometimes it,
Or perhaps people are, it's difficult for people to understand what is in their best interest, you know? One of the two of those. Generally, like, you know, according to one conceptualization, we're kind of like we're trying to be maximization functions for like our own good to some degree, but we just don't know what's good for us, you
Yeah.
know?
So how can it be example work? Say like what we put down. What the above average would be.
Well, you need to calculate it, right? You need to calculate the average. So, what's the formula for an average? Well, you can use Google. Not Java, just average formula. You should be able to interpret it. So that's using high math notation. It's the sum of all of the elements divided by the number of elements. The first thing, that's the first thing you need to calculate. If you need help with the syntax for this for loop, you got a working one, right?
So, question, so am I returning another array of all the higher numbers?
Oh, no, just the number of them.
Oh, like how many of them are
Mm-hmm.
high, okay.
I mean, that would so the number of them that are higher is actually necessary if you want to return an array of all of them that are higher, because you would need that number to initialize the array you would return.
Because right now, I think that's my problem is my return value is inside this for loop.
So as soon as you hit that return value, that return statement, the function will kill itself.
But why?
Because that's what a return statement does.
Oh, yeah.
It terminates the method, right?
No, I think this needs a return outside, right?
Yeah, so, just make a variable count and increment it there, and then
Oh,
return it,
yeah, actually, right.
right?
Yeah, actually, yeah. Interesting feature.
Yeah, so don't make it more complicated than it needs to be.
Yeah. Didn't think of that.
Okay, you want a challenge?
Yeah.
Write me a reverse algorithm.
A reverse algorithm?
Yep,
Like that flips the list?
yep, okay, yep.
How do you return arrays, or do you only just print it?
Oh, it's easy. You just do that, and that's it. Sorry, I should have given you something to do a little earlier. You're very sick? Okay.
I'm constantly I'm so busy, that's why.
Oh,
I'm living here.
yeah, that's
I
okay.
tried to keep it.
Oh.
I couldn't.
Well, yeah,
Okay.
I didn't take the time for the class.
No, so good.
Is there a way to turn off IntelliJ's autocorrect thing?
Probably.
Like, I believe it would be settings.
It should be. Like, it depends on what you want removed, right?
Yeah.
It also is like, it's called inline completion.
Inline completion.
Enable local full line completion settings. There's a checkbox apparently. It's under Editor General.
Okay.
But we won't have to call the Editor General. That's Auditor General. That's a joke. Not a very good one. Yeah. Very good. So, you guys want a few more minutes, or would you like me to show you how that one works? All right. So, in order to calculate which items are above or below the average, you first need to have the average. This is something that it might even be useful to encapsulate as its own method. So, public static double, since calculating an average requires division, we're probably going to be dealing with partial decimal values, so we should have a data type that reflects that. Average. Takes an array of integers x. Doesn't have to be called x, it could be called anything you like. There we go. So, we need a sum, and we need the number of elements in the thing. sum works the same way that it did before. For int element in X, sum plus equals element. Return, rather than returning sum as we did in the summing algorithm, we are returning sum divided by the number of elements in the data structure. What is the number of elements? Do we have a thing for that? An easy, convenient property?
I just use style length.
Yep, that's it. X dot length. Very good. So now we have an average function. Very good. So, number of elements above or below the average. Public int, public static int, number above int X, number above average. There we go. All of my students are above average. That is categorically false if the average is calculated on the students. Oh man. So there's this line from George Carlin that people like, which is, you know, when thinking about people, think how smart the average person is, and then half of everybody is stupider than that. But here's the thing. You can't actually say that half of people are below average. It might not actually be exactly half, right? Outliers will pull it one way or another. Anyway, so if X is greater than average of X, there we go, or X at int, it needs to be in a loop, for int E in X is greater, there we go, and E there we go, boom, aha! Keep a count, int count is equal to 0, count, plus plus, return count, aha, there we go. Now, this is okay. This will work. Huzzah. Here's the problem though. Efficiency. When we call the average method, how many times are we calling it?
Depends on the number of arrays, or number of the elements in an array.
That's right. We're calling it once for every element in the array. Now, this method itself, how many times does it execute that line?
Also the same.
The same. So in fact, we have gone from an algorithm which is proportional to the length of the array to an algorithm proportional to the square of the length of the array. That's a lot more runtime. So, how do we fix this problem? Caching. Nothing very fancy. You pre-compute the average before you enter the array. And then you store that in a variable, and you use the variable. By pre-computing the average and not recalculating it for each iteration of the loop, you go from an algorithm which you kind of like max out your ability to actually compute this at probably you know, as it was before, you probably wouldn't functionally be able to calculate anything above 10,000, maybe 100,000 items, right? But now you would functionally be able to run this algorithm on billions and billions of numbers with the same hardware, right? this type of thing does matter, particularly if you're trying to write code for servers or mobile applications, where power consumption is like a real problem, right? Now, if you're doing that, you're maybe not doing it in Java anyway, right? Because Java is not the most efficient system, right? You probably would, you know, if you're working in like a environment where you care about this level of efficiency, you're probably using C++ or you know, like Rust or something. But for Java, you know, I just, you know, I like to sprinkle things like efficiency throughout, because, you know, I want to get you guys thinking about like data structures, you know. The data structures, of course, will turn you into a wizard. Are you doing data structures?
Yeah, that's semester 4, so yeah, we
Yeah.
were learning about how to, what you just did, but.
Yeah. Are you a wizard yet?
I'm becoming one.
There you go. There you go. All right. Let's see here, what we got? You've got too many braces. That's one. You don't have this. That's actually what this one should be called. So rename that to average, and you'll be good. All right. Good work, crew. Thank you very much for your time and attention today. I hope that you all have a couple of recommendations for the test tomorrow. Number 1, try to get some sleep tonight, right? I know I sound like your dad, but go to sleep on time. You'll thank yourself in the morning. Number 2,
My dad.
yeah. Number 2, eat breakfast. All right? I know a lot of people tend to skip breakfast, but like try to get something in you, because like, you know, well, that's the thing, is if you don't have time for breakfast, you should get up a little earlier so that you have time for breakfast. How do you muster the energy to get up in the morning? By going to bed at night. You know, you see how it, yeah. So yeah, trust me, there are many, many good reasons to eat breakfast in the morning, and you should eat protein. Don't load up on Count Chocula, okay? Count Chocula is like my favorite bad for you cereal. So, yeah, so eat some protein tomorrow morning if you can, and I'll see you for the test. 9 a.m. bright and early. Don't be late.